Hey guys, welcome back. So today we're actually be starting on a Minimoog in this series, and this Minimoog actually belongs to John. So John, this is your Minimoog, and we'll be bringing you along on the adventure of this one as well. So we're going to treat this one just like we did the Memorymoog. I'm going to go through all the little details of it and bring you guys along. This is going to be a little bit different because John actually likes the way it looks. He likes the kind of aged appearance. And so we're going to try to, stick with that. We're not going to do the hardcore kind of restoration on this one where we actually delaminate all this and stuff like you've seen in my earlier videos. So we're going to keep it looking very much original, but we're going to really focus on making sure this thing is mechanically sound and electronically sound. That's what we're going to be doing to this one. The keyboard definitely needs new bushings. It's really clanky and really noisy. So it needs new bushings, and when you look down the keyboard, the keys are actually kind of wavy, so they're not aligned properly. So we'll take care of that. And, just kind of address it, condition the wood, make the wood condition so it's going to be less prone to cracking and that kind of stuff. And, of course, the obvious thing is on the back. We're missing some hardware, just one or two screws there. We got some hardware laying in here, and there's some loose hardware inside. So we got to investigate that. But the power cord, that's a dead giveaway. We need to replace it. It is absolutely just rotten. I mean, there's tape all over it in different spots, but you can see like you can see the wiring inside of it there. It's just rotten. So it's time definitely for a new power cord, and we'll get that fixed up. But this is a 73 Minimoog. It's actually got a birthday coming up. It was built in April of 1973, so it's actually, we're working on it the month it was actually made. So serial number 2312 is the serial number of this unit, as you can see. Kind of weird how that's stamped. I don't think I've seen one that crooked before. It's pretty crooked, but that's factory. But 2312 is the serial number. And like I said, it's in good shape. And I have to give John credit. He actually made this top bar for his. It was missing this when he got it. And so he made this one. And he did a very good job on it. It's a little thicker than what factory would have been, but actually that's not a bad thing at all, because it's less prone to crack. So that's really nice. All we got to do for him that he didn't have a chance to do was we got to drill the holes in it for the screws. So we'll be doing that. But overall, it's a really nice looking Minimoog, and we're going to bring it back to life. So let's get started here on some testing. So the first thing we're going to do here, because this power cord is in such rough shape, I want to make sure it's not shorted and make sure we're okay there before we do anything else. So let me take my meter here. I've got it set to ohms. We're going to connect it to the prongs of the power cord here, and should read an open right now, and we do. Let me flip the power switch. Yeah, 74 ohms, that's good because you're reading the windings of the transformer now. So that's good. So we don't have a short. So that's good. Let me go and check, make sure our ground is there. So if we connect to the third terminal of our power cord, I'm just going to probe the chassis up here somewhere. That should be a ground reference for our chassis. We should read pretty low ohms there. 140 ohms. We're probably getting a little, as I said, just from bad connection, but yeah, at least we're getting something there. So we are reading some ohms there, low ohms like 80 ohms, like 100 ohms. It's kind of fluctuating, but so the power cord's okay. I don't see any shorts in it or anything like that. We can also just connect back to our leads here of our common and line connections, and just make sure we can wiggle this cord. Make sure we don't have any shorts show up here. So we wiggle it. So I hadn't tried to apply power yet. So it looks good. So our power cord looks like it's safe enough to use. We will be replacing it though. So now what let's do, since we know that's good, let's go and pull the back panel off, and we'll start there. Alright, so we're now looking inside this thing, and for those that don't know what they're looking at, this is the VCOs. Right here, this is the VCO board. It has your 3 VCOs, wave-shaped circuitry, and the negative 5 volt supply for the boards, as well as your voltage sensing circuitry for your power supply. Next to that, we have the filter board, which has your transistor ladder filter, your VCAs, your 440 Hertz oscillator for reference tuning, your external audio input preamp, and overload driver circuitry. And then behind that we got the power supply, and then behind the oscillator board we've actually got another card, and that's your keyboard circuit and contour generators on that board behind there. And something I'm going to bring up real quick, I always bring this up on Minimoogs as far as how you can tell the era of Minimoog, but I want to bring up something else. So there's a book out that actually I had part in, which was I was really honored to be able to work with Joe Silva and the team here on this book. But we actually talk about in this book some of the changes that happened in the Minimoog. So for you guys that are interested in a really hardcore book on the Minimoog, go check this book out. I'll put a link to it in my this video description, so you guys can go check that out if they're interested. But pages 72 back is actually where I actually helped edit this book, and actually the Minimoog that's pictured in that area is actually my personal Minimoog. It's serial number 1548. So kind of cool thing there. I was really happy to be a part of that, and thanks again Joe Silva and the whole team there for allowing me to help with this book. It was a real honor there. So these are RA Moog circuit boards for this era Minimoog. This is a 73 Minimoog. They made huge revisions starting in 74. So December of 73 they started revising all the circuit boards, and in January of 74 all the circuit boards changed a little bit. And one of the things that changed was that they no longer said RA Moog Incorporated on the circuit boards themselves. They started just saying the Moog. They just had the Moog logo with Moog written out on them. And that was one change, but the big change was actually in some of the circuitry design. And we see something majorly change right here in the filter circuit. As you can see, we got the CTS trimmer pot right here. And these other trim pots here, those are rheostats, which you see that as metal can style. So in 74, they actually revised this board and redesigned it. So this CTS trimmer became a rheostat just like those. And that was a big change that happened. This is basically a very similar board to what you find in the RA Moog Minimoogs as far as this filter circuit goes. And they just revised it in 72 to have the CTS trimmer so they could actually scale the filter. Before this, you couldn't really scale the filter. And that was something they actually just really kind of added into the circuit board. They modified the circuit board, stuck this in there, and soldered it in and cut tracings and made it work. That's kind of how these circuit boards in the earlier Minimoogs worked. And so by 74 they revised this so it was actually a retraced board. Everything fit in there really nice, and they gave room around the circuitry to hold that rheostat. So that was a big change there. But just a little bit of history there for you. But looking at this Minimoog, I'll show you what I found. We'll now go into what was causing some of the problems. If you look at our filtering capacitors off our rectifier circuitry, they have actually started leaking out. You can see how the seal in that thing is all oxidized, nasty looking. These caps on both sides have gone bad. So they're probably dried out. And so what these caps do is you got your rectifier diodes. So you got your transformer. We'll start here at the transformer. I explained this before, but I'll explain it again on this video. So your transformer takes 120 volts in, or 230, whatever your voltage is in your country, and it converts it down to 20 volts AC. And so it's still AC voltage. So it goes to these rectifiers, which chops up the signal. So you'll have a positive slope, and it just captures just the positive slope on one half of these rectifiers. The other half of the rectifiers are actually the negative slope. And that's how you get your plus and negative voltage rails. That's how it works. But it's still AC. It's what you call pulsating DC. It's actually what you refer to it as. Because it's no longer a full sine, it's now just the tops and bottoms of the sines separated out. It becomes unregulated DC with these caps, so that either positive or negative slope of that waveform goes in these caps, it charges cap up, and this cap actually will balance and smooth out that pulsating DC and make it unregulated DC. So that's what happens. And then what happens, it goes out to your power supply, and then your power supply is actually what does the regulation of that plus and negative 20 volts roughly. It brings it down to 10 volts and it regulates it, and it also, the power supply works off getting feedback from voltage sensing and current sensing to help regulate that voltage and clean it up, and that's how that all works. So that's what this does right here. So just a little bit of more information for you there, but that's how that all works. So these caps being bad, what happens is it comes in here, it's never properly filtered, it gets into the power supply, still very noisy. The power supply really can't regulate that well. It's just too much to try to regulate off of, because you still got that 60 hertz in there. It causes a lot of problems. And so that's what's going on with this Minimoog. I can guarantee you based on what I'm seeing. So that's where we need to start before we even power this thing up. But let me pull the boards out of this thing and I'll show you what they look like on the back side here. Alright, I have all the boards out of this thing now. Something I ran into while removing these boards is we're missing some of the hardware that holds our edge connectors in place. As you can see, it kind of gave me a little fight there. This one's missing, and then this one here is real loose. As you can see, it's about to fall out. So we're missing some hardware there. I mean, these are all very loose. These are okay. So I'm guessing probably what happened is, I'm not 100% sure, but I bet somebody loosened these trying to get the connectors to make good. I bet these flag connectors need to be tightened up. I bet you that's where our problem is there. And so instead of tightening the flags, they loosen these just so they could kind of work them in. That also explains why they put this between the board, trying to make that thing flex harder, trying to make a better connection. So I bet you that's what's going on with it. But here's the inside of it. Kind of see what the jacks look like here, all your rotary switches, these Allen Bradley potentiometers. Really good stuff there. You won't find this in the reissues, that's for sure. But if we look right here, here's our actual piece of paper, and I think it's loose. We'll pull it out and re-glue it. Let me pull it out here. So looking at the paper here, this thing was actually, so that final assembly was done on 3/13/73. So that's when the final assembly was. So it's actually a March 13th, 73 Minimoog. So that's when this one was actually made in March. So that's pretty cool. So we'll see, ELF is the assembly initial there of the person that put this together. But pretty cool. That's what makes these early Minimoogs so cool, because you don't find this in later Minimoogs. Really neat stuff. But we'll glue that back in there once we clean everything up really good. But just once again, just a nice look inside there. And of course, once again, you can see our old rectifier diodes. And it's like, man, it got a little warm. You can see some discoloration on some of those. So the rectifiers may have got a little warm from that thing dumping current. If these aren't charging right too, it'll burn up these rectifiers. So that can also play a factor there too. But alright, well, let's get this board out. We'll get this thing serviced. I'm going to upgrade it as well. There's an upgrade you do these to add extra cap, and it just kind of helps with regulation and noise. It doesn't hurt sound. So just to be clear, that does not hurt the sound of this unit. It just makes it a little bit more accurate as far as the tuning stability goes. So, but it doesn't affect the actual tone or anything of the instrument. Something else I will show you real quick is just an example of what I was talking about, the Moog versus Moog Music badged boards. So this is the power supply here, as you can see. And you can see it says Moog right there. See So it says Moog on the actual board itself. There it is, Moog. Well, here's a power supply I've got from a 74 Minimoog. I'll just kind of show you that it no longer says Moog, it just says Moog Music right there. So that was some of the revisions they did, was actually re-badge these boards in 74. So 71 to 73 would still say Moog, and then from 74 up they would just say Moog. So that's some differences there for you. But they also do some board changes and component changes as well. But that's one of the bigger things they did there, besides the rheostat change for the filter board. This board here, it looks like it's had some work done to it. You can see the connector down there. So somebody soldered it or something, so I have to clean all that up. So we can get that to clean up. I don't know if it's cracked. It looks like, I don't know if they was trying to fix something, like maybe it got cracked and they were trying to fix it or what. We'll have to look into that, but that's definitely a problem there. The other boards look okay. This one's had an update to it. This is your keyboard circuit and contours, envelope contours. So that's probably reduced popping noise, I'm guessing. But yeah, very much original. There's your envelopes or your contours. There's your keyboard circuit right there. And then here's the filter board, and it says Moog on it as well. So these are all Moog circuit boards. They are original to this unit. There's your filter, that CTS trimmer. But also you can see that transistor ladder filter. That's, you can see why they call it a ladder. It looks like a ladder there. All discrete. Unlike other Moog synthesizers, the Minimoog was the only one besides the Sonic 6 that had a fully discrete transistorized ladder filter. About every other synthesizer Moog made incorporated a transistor array chip making up part of the ladder, but the Minimoog always had this ladder. So just a little bit different design there. So I hadn't looked at the oscillator. Let me move this board here out of the way. That's my power supply board there. I'll do all this one-handed here. So here's the oscillator board. Let's see if it's Moog as well. Should be. Yeah. See right up here it says Moog. My camera will focus. There it is. Moog Incorporated. So yeah, that's and it looks okay. I don't see any solder work on it. It looks like it's still clean. But we just got to look into those connectors and see why somebody took the screws loose in them, or maybe they just came loose. I never have seen that come loose like that though. So that's, it looks like somebody's been in here trying to make it work better or something. But anyways, let's jump back on this guy. Alright, we have a new power cord installed. We got the rectifiers replaced and the filter caps replaced and upgraded there. I just stuck the boards back in just like it sets. Hadn't done any kind of repair work to it. We're going to see what it does now. So let me go around here. We'll power it up. I've already got it plugged in. I got to take my prop here and actually reprop it like this right here so we don't have these boards touching against the chassis there. So there we go, like that. And let's go around here and see what it does. Alright, let's test this thing out here. I've got the amp connected now. And let's see what it does. Make sure my volume's set at a decent level. Make sure everything is kind of set up here. Let's see what it does. We get something out of it. Well, it does seem to work on oscillator. Intermodulation, I can kind of hear it. It's actually off the that's off the actual LFO circuitry here. So oscillator 1 and 2, oscillator 3. That's bad contacts there. Let's way out of tune. That part was working, so oscillators are working. That's good. They sound pretty stable. I mean, I hear a little stuff going on, but it's just normal maintenance. This is the noise source works. The noise source is very weak. Dirty switch. Yeah, our noise source is too low in volume. We got a problem with the noise source. See if the filter oscillates. Like it does. Just make sure it tracks. 440 hertz is not working. There it goes. Filter sounds like it works pretty well. Make sure it self-oscillates at the right frequency that starts the oscillation. It's pretty close. Sure the envelopes work. Sounds good there. So our envelope sounds like it's working for the filter. Sounds good. Let's open this filter up here. I want to check one thing with this era Minimoog. Sometimes if you turn both the tacks up, you have a separation in the oscillators. This one doesn't have it. That's good. Loudness. These early Minimoogs, they just sound great. So that looks like that's working. Our sustain should work. This is going to be getting the dead zone too, because you can just press this wheel. Without dead zone, I'll show you what they sound like. We'll just turn one oscillator on. So I can just touch that wheel. that's where the dead zone really comes in there. Let's see if the modulation bus works. Let's go here. It works. See if it modulates the filter okay. Sounds good. So that's working. Sorry for the train going by here. Let's open this filter back up. Let's see if glide works. It's loud, isn't it? Glide works. Let's see if decay works. That works. So this Minimoog overall, it seems like it's fairly functional. So I think replace those capacitors and that power cord has helped a lot on this thing, just based off what I was gathering from the from John, who owns this one. It does sound like it's a little bit more healthy. So yeah, I can definitely say we need switches cleaned. We're going to go through the whole process here, minus the delamination removal. So yeah, let's just get started. I'm going to pull the circuit boards back out, and we're going to go through the circuit boards, do maintenance on them, and get it all back together, and going to rebuild the keyboard as well. We might start with the keyboard now, since I've got this part of it at least working. I think that's where we're going to start. We'll start by disassembling everything, so I need to condition this wood and start the conditioning process. So we'll do that, because I put several coats of conditioner on these things over the course of a few days. So that's what we'll do here. But alright, well, this is a great Minimoog. It looks like we're making some great progress here. Alright, so now we're actually ready to pull the keyboard. I'll just kind of show you, because I got to do this with it on its base again here. But we're going to remove these 4 screws. We got 2 screws here, 2 screws there. Then we got our spacers. You go between the keyboard, you can kind of see this wire is here usually plugged in. We got a Sense Jones connector going between the keyboard and the harness. But you might consider a spacer back there. Yeah, there's a spacer. Kind of see it back there. It's just a little block of wood there. Something that's interesting to me, and I've only seen this on one other Minimoog, is that this is actually particle board material they used as the chassis supports. I've only seen it on one other Minimoog. I don't know if somebody was new on the job or what, but it was about the same era Minimoog as this one. So this, and I forgot what cylinder it was. I have to look back at my records and see. But it had the same composite board. Usually on Minimoog chassis, this is a good piece of solid wood right here. So I don't know what happened there, but I've only seen this on one other Moog, but this is still in good shape. The other one I worked on, it had a Kenton kit installed, and one reason I don't like the Kenton kits in particular in the Minimoogs, now Kenton, I like their Memorymoog kits and stuff, but in the old Kenton kit, they'd actually have to cut out part of your chassis. And so if this is particle board material and you cut this out and it's already not a very stable material anyways, you lose support. And like I say, this one's in good shape though. The other one I had, it was cut out for the Kenton kit, but it also had been wet, so it was all swollen, it was flaking, and so that was quite a mess. But this one here, like I say, it's pretty solid. It's just it's rare I see this material used in these chassis, so I just want to make a note of that for you guys. That's something that's kind of historical for Minimoogs. Not many chassis have this fiberboard material, and not that that's a bad thing. You really don't want this material in here. Alright, so I just gave this wood a nice wash down just with a damp cloth just to get all the dust off of it. And I'll show you what I do here. So we're going to do the first treatment of conditioner. I use this stuff right here. It's made by Howard. It's called a Restore Finish, and I use a natural color, or neutral. That way we don't add any coloration using this. It's kind of like Old English, but it's non-colored. And then once I'm done with all the processes, I top it off with this Feed and Wax by Howard as well. And that just kind of seals and waxes everything and makes sure the wood's going to be well conditioned. And what I'd recommend is usually my clients, when they do this, is use this stuff maybe once a year, just freshen it up. Just kind of keeps your wood in good shape, keeps it from cracking and getting brittle. So we're going to take this right quick. Let's put a little bit on my applicator here. Get some on the applicator, and you can kind of see, just kind of work it into the wood. And it'll drink it up pretty quick because this wood is pretty dry. I'll do a couple of coats of this stuff. You can kind of see the process here, and this is basically what happens here. So I'll do this all the way down the unit, and it looks shiny. It'll go. The shine will kind of go away as it drinks the stuff in. And this stuff's safe to get on the badges and stuff too. It doesn't hurt anything. Alright, and there it is after the first coat. As you can see, it looks really nice. And I want to go and get that started before we do anything else, so I can put a couple of coats on it. And then we'll do the final feed and wax once I get ready to reassemble everything. But as you can see, it brings out the wood grain. This got some beautiful wood grain in it. Right here. Looks really nice. It's got a little scratch right there, but that's, you know, history marks. Yeah, it cleaned up really good there. So now let's get on to the keyboard rebuild. Keys are now removed. You can kind of see how dirty this key bed is. We got some hairballs in there. We are missing one of the return springs for the bell crank here. As you can see, let's see if I can get in here. I'm trying to hold this camera weird. But if you look right here, that's supposed to be a spring that goes underneath there. You can see them like in the other ones here. Let me see if I can zoom in there for you. You can kind of see the springs up underneath there. That was missing one. So what that would cause a note. The note would return fully, the key would, but the contact would probably sag a little bit, be more sensitive to trigger notes. That's something I see quite often here. But so there's that. But also just to kind of show you what makes up a Pratt Reed keyboard here, because you've seen the Memorymoog keyboard, and you can now see how more complex the Pratt Reed design is. So we got the keycaps, which are plastic. They're just plastic keys that So of course I'm going to be giving these a good wash because you can see they're dirty. So we'll be washing those up. One reason I took those off. Then here's the actual key. So you can see it's metal. And then we've got our springs. You got different tensions for different keys. So the white keys are, in this case, blue. The other ones are purple. And so then you can actually physically see a tension difference. And the way they're compressed, they're different. But yes, let's look at the keyboard. Now these are the key bushings. These are what gets rotten right here. These gray colored things. These are real stiff. That's what makes the clunky keys. If these are missing, that'll cause your key to be out of alignment. So that's a real common thing there. But these are also sometimes missing here. These are little lobes that actually ride underneath these keys. So when you push down the key right there, you can kind of see that little mark in there where it rides. And the camera will focus there maybe. You can kind of see that little clean spot. That's actually where that lobe rides on the key. So you get downward motion, it pushes down on this, and then underneath it's actually moving the contact forward. That's how that works. So that's how all that works together to give you your key action. But anyways, I'm going to get this all cleaned up. We're going to place the key bushings, and then we'll clean the key contacts and do a full alignment. I've actually got the factory alignment tool for the print read keyboard, which is really helpful. So something I will show you right quick. I'm going to replace one of the springs in this. As we mentioned, we had lost one of these springs. You can see it's just a little bitty spring. I'm going to show you how to do this because I get asked this question quite often. How do I reinstall these springs? Well, I've got a tool here I use. It's actually just a clip. It's a little micro clip. And I'll actually squeeze the spring, compress it down in the middle, like that right there. I don't know if that'll focus in or not. I'll compress it in, and I actually just go under here. I'll try to do this where I don't block it with my hand. Find that little dimple there, alright? And I just set it in here, and I release it. I gotta make sure I get it on the... It's tricky, just the same. And I release the tension, and there we go. And there's our spring installed. And that's how I do it. Alright, I now have all the new key bushings in, everything lubed up and cleaned. I did clean the lobes off camera. I pulled them off and cleaned all the old grease off of them. Now you can see all the bushings are nice and lubed up and ready to start going back together. So we're going to start putting the keys back on. And of course we're going to wash the key caps, so we're going to clean those up. But as you can see, this is a big old bag of key bushings I have. I buy them by the bulk because I just use them so often. But anyways, let's get started putting this thing back together. Alright, we now have the keyboard all back together. All the strings are reinstalled, so this part of this keyboard's done as far as getting the bushings and everything set up. I will be aligning it once we get the key caps back on. This is actually the factory tool used to align the print read keyboards. I'll kind of show you how I do that as well. But now let's wash these key caps, get this cleaned up, and we'll start reassembling after they dry here. Just gave these keys a good spray with my cleaner here, and you can see all the nastiness coming off of them. We're going to get them rinsed up here and get them drying. I'd say those keys cleaned up pretty well there. Of course, you can see how dirty the water is. Not too bad. But now we're going to go dry these keys up. Alright, so we wait for the keys to dry here. We're going to turn our attention back to the unit. And we're going to get the knobs pulled here. And we're actually going to start some electronic work. Cleaning switches, cleaning pots, cleaning the interface panel. Kind of start here and just give this thing a good cleaning while we wait on the keys. Alright, I now have the interface all cleaned up here. And actually our keys are dried, so we're going to turn our attention back to the key bed. So we'll get that keyboard reassembled and start from there and then work our way back to the actual potentiometers and that good stuff. So I'm going to just leave the knobs off, but as you can see it looks much cleaner than it did already. Alright, the keys are all reinstalled here. As you can see, they look really good. I polished a few of these black keys out. I actually wet sanded them and polished them. There's some pretty deep gouges in a few of these keys. And so got those cleaned up. And they look way better than they did. Now actually I let these things set for a day before I do a actual height alignment. We'll look down the keyboard here and just kind of do a visual how bad of alignment it is. It's not too bad. You see a little right there in the middle, you can see it's a little out of alignment. But overall it's not bad. It's actually in pretty good shape. Alright guys, it's a new day here. I let this keyboard set overnight and let all the bushing kind of settle in a little bit. I'm going to show you how to do the alignment. So I've got my own way of doing this, and I've actually made some tools to make this a little easier for me. Real simple. I got a block of wood here, and I've actually got some lines drawn. As you can see right there, the red is too high, and the actual kind of penciled in line is where we want it, and we got to mark this too low. So I kind of want it right between these. That black line is about where I want it to be. This is for a later Minimoog. I've also got an early Minimoog reference because the keyboards are different. So I've made this tool, makes it a little easier. And all I'll do is I'll check the front of the keys to a block of wood, make sure they look okay here. And this one here is really, really, really close. It needs to go up just a hair, but not bad. So what I do, I'm going to see if I can figure out how to show you guys this a little bit easier on camera. Let me bring you in and I'll just show you real quick. Yeah, so look at my block of wood here. I'm looking at the front edge of the key, and you can see this first key comes right to that black line, but as we move down, you can see the gap right there. It changes, and these are all sitting a little below that line. So I'm going to raise them up just a hair. This is how I do it. I'll just go down the keyboard. You can see some of these are getting really off there. We got a huge gap on that one. If we go higher, you'll see it comes back in. It's getting closer to that spec. So it definitely sags in the middle, is what I'm seeing based off this block of wood. Basically, I'll just go down the whole keyboard like that. And what I like to do is I'll use this block of wood and I'll adjust keys to that level throughout. So I usually use like the F key reference. I'll raise the F keys. So all the F keys I'll raise up to the right height, and the C keys. And I'll work my way in between note sets to get them in the right alignment, and that's how I do it. But I'll show you guys the process here. Alright, so now I have all the keys kind of set where I want them for the F and C notes and the last notes. I've already got those raised up. So now what I do, I just visually look down the keyboard to do my alignment. So I actually just get here on the end and I just kind of see where these keys need to go. I don't focus on the black keys, I just focus just on the white keys. And I go in here with this tool and I'll just kind of raise it till it's even with the keys I've got set, like so. And you can probably see how wavy this keyboard is right now in camera, but that will change. Those. Those keys were pretty low. Basically what I'm doing, I'm just looking, I'm using the keys I got set as my reference point, and I work on the keys between them. Make sure they're not waving or doing any kind of weird. This tool right here helps a lot though, this factory tool. It really allows me to get in there and there's that one. I do a lot of things by eye once I have everything set. Anyways, this is the fun part of it. This is what. And you can see just from this video how complex the Pratt Reed keyboard really is compared to like the Matsushita keyboard that we had on the Memorymoog. Alright, our keys look straight. They look good. Make sure action feels okay. They look good. So there's those. Now we got the black keys. Now the black keys are pretty simple. What I do to those, get comfortable here. What I do to these things is I actually look at the fronts and I set it to where the lip, where it starts that curve down. I set it where that lip just comes to the top of those keys. I'll show you in a minute. They're a lot easier to set than the white keys. Once you get the white keys set, you can pretty much use those as a reference. You can also move them side to side with this tool as well as if you got a gap offset. There's this keyboard here, it's not too abused. I've got some of these in that are really abused, and those always take a little bit more alignment work than others. But this one here is pretty straight. Like I say, it's not too bad. Again, our action set, what that's going to do is going to allow our contacts to travel correctly. And it's also going to give the keys a good action, good feel. There we go. So there's our black keys all set. So they all feel okay. So they're not dragging or anything like that. Good there. I'm just going to do a top angle look, and I'm going to make sure we don't have any that are just really crooked here. That one right there, that note right there is a little offset. I may give it a little adjustment to the side using this tool. Just a little bit. Yeah. It's good. Still got plenty of action in that. Still plays good. Is that one adjusted? I think that's the only one that was a little too sideways. I think this last sharp here. Hair. There we go. Alright, that's good. I'll show you on camera what I'm talking about with the black keys. Yeah, so looking at the front of the black keys here, you can see that lip, where that lip just starts to curve. And what I do, I set those to where they're right at the front lip of the white keys. They're not too high. And that gives you plenty of action and motion on your black keys and white keys. Now you can just see down the keyboard here how great that looks. And since we let the bushings settle last night, we know they're not going to move anymore. So that's one reason I let them settle overnight. What I have done in the past is I do the alignment right after doing the bushings, and as this thing sets with a little bit of that pressure on, because now it's new rubber with the keys, they can kind of change a little bit. So I give them a little bit of time to settle, as I call it, before I do the alignment, and it just makes things a little bit better in alignment once you put it back in the unit. Otherwise, you may have to go back and do another alignment. So that's something I have discovered through the years of doing this. But yeah, that's got the keyboard pretty much rebuilt. The only thing we got to do now is clean the contacts, and I'll kind of show you here how they look real quick. So now looking at the other side of this keyboard, you can see the contact set and how it kind of works. I'll lift up on it and kind of see how, when you pull a note, how that downward motion makes it move forward. That's how that works. That's that cam and lobe action there. But your contacts, I should kind of show you how these things work. So you got two sets of contacts in here, and this front rail, so you got the front bus, which is your actual CV voltage. This back bus is your gate, or S-trig. So you want to actually make it, all your alignments, so that your gate is connected before, or I'm sorry, your CV is connected before your gate. That way you got CV reference before it triggers. Otherwise you get that really squirrely note kind of problem that you heard in this actual unit earlier on. But we're going to polish these up. They actually look like they're in good shape. I don't see any damage to them. I'll sometimes see people come in here and don't do this. Don't use steel wool to polish these bus bars. Don't do that. What I actually use, I use a jewelry polish. It's a very light, very light abrasion. Something that will not hurt the plating on these things. And of course you can see this is not polished yet, and you can see just kind of how nasty they look. Whoops, if I can get this thing to focus, not zoom in too far. But you can see how they're kind of discolored, but the plating is still there. I don't see any problems with the plating. What happens when you use steel wool in these things, you actually eat the plating off, and it's more likely to corrode and have contact issues and that kind of stuff. So don't ever use the steel wool method that I've seen people do in the past. That's terrible for these things. So I just finished polishing out the gate rail. As you can see how shiny that thing looks all the way down. Hadn't polished the front one yet. You can see the difference. Just how different that looks. So they clean up really, really, really well when they're in good shape. Just looking all the way down the keyboard. And there we go. Compared to that one. It's a big difference. I now have all the contacts polished out. You can see how great that thing looks now compared to how it did look. So just a good polishing makes a huge difference on how these bus bars turn out. You can see all the way down. Looks nice and clean. Also, something else that's kind of cool is here's our date code again. March 30th, 1973. That's when this keyboard was manufactured. So using the same method for the key buses, I also polished up our St. John's connector. The plating was still good on it as well. So I cleaned it up real good, and now it'll mate real good. So I think now, with the keyboard done, we're going to turn our attention back to the unit. We'll start cleaning the potentiometers and switches, and then we'll move back to the circuit boards and get those serviced, and just continue on here. So now I'm going to start cleaning the pots on this thing. I've got this one removed. I'm going to show you how to do this. I never drill holes. I never cut it with a grinder like I see some people do. I like to physically open these things up so I can inspect the carbon, make sure there's not a lot of wear in them, and I'll show you how I do this. So all you got to do to get this thing open is I use a little small set of, so I can get that in my camera, these small sets of channel locks. And I'll take it and I'll bend the tabs that hold the back cover on. I'm trying to do this while looking at my camera screen. Like that right there, and then you got two on each side. So you bend those out like so. Be kind of gentle with your wiring because you got some resistors tied in up here that you can't actually break the resistors. I've done that, put it back together, had things that didn't work, and it's because I broke a resistor leg. So we'll get that thing opened up. And then what you want to do is these have a thin glue on them, so you can't just open them up. But I use a heat gun, heat it up, and I use a little small screwdriver like this right here. And I use that to pry between here, and I'll show you in a minute. Let me get the heat gun on it, get a little bit warm. This separates those glues is what this does. Allows that glue to melt. Should be good. Set that back down there. And I'll take my screwdriver here and I'll wedge it between those two points we just bent. Let's see if I got it hot enough. Yeah, it's going. Just being very gentle. So we got a gap in it now, and I can just kind of open it up like that. So first things I can do is I can look inside this thing, see how much carbon we have in that one. You can see that one's got just a little bit in there, which that's normal. You'll have a little bit. But the next thing I'm looking at too is I'm looking to see how, I don't know if you can see this on camera or not, but this is your wiper that you're moving. And let me see if I can zoom in right here. I'll see if I can capture this for you. Well, I'm looking at, I actually look at there's a carbon. Let's see if I can, yeah, you can kind of see it there. So if you look where that thing rides, you can see there's like a little carbon right there. and that looks great. It's actually in really good shape. But then what I'll do is I'll take it and I'll flush it out. So I'll just use some deoxit just to flush it. Make sure we don't have any debris in there. And I've got you guys zoomed way in there. And then I'll just kind of work it like this. Kind of get some of that worked in there, and that's really about it. These are sealed, which is really nice. What I also do too, let me zoom you guys back a little bit here. What I also do is I'll take this and I'll wipe it out on the inside. Get any of that carbon powder that might be in there. Just kind of blow it out. And I'll reassemble it in reverse order. I'll take this, put it back on there, bend the tails back in, and remount it. And that's how I do these. I've already actually cleaned all the switches and everything. You can see the little black marks I've put on my, actually do it like this, leave you guys on the tripod. You can kind of see like these little black dots I've put on the back of the potentiometers. I just mark those as I clean them. And yeah, right here, you can see. And so I mark them as I go through them. But yeah, this Minimoog here, I don't believe it's a very heavy used Minimoog. It actually looks really good internally. Every potentiometer had about the same wear, and it's very minimal. Sometimes I get them in that's been heavily used, and there'll just be tons of carbon inside these housings, and it'll actually be worn down. That carbon that is on the wiper, and it'll almost be metal against the track. So you just kind of have to monitor those. And but as you can see, those are great. 50 years and they're still fantastic. You don't find that anymore, most of the stuff. So before we move on, I'm actually going to do the final treatment of our feed and wax, because I'm actually getting this thing ready to set the keyboard back in. It's a lot easier to do all this with everything out. So we're going to do this right quick, and then we'll actually reinstall the keyboard, and then we'll come back to the circuitry once again. So let me go and get this thing opened up here. So you want to shake this stuff really good. It applies a little bit different than the other stuff. It's a little bit thicker. Usually I'll just give it a few little drops here. Something like that right there. A little too much. Perfect. Let's kind of work it in here. Hey guys, it's a new day here. I actually let that feed and wax set on this unit overnight just to make sure we get a good coat. As old as this wood is, it's always good to just make sure it gets as much as it can. And so I've wiped it down, I buffed it, and you can see it's got a nice shine to it. The shine will go away a little bit. That's some of that's still the oils. But now that is kind of a wax, so it will kind of wax this wood and keep a little bit of a shine on it. But mostly it just protects the wood. But you can just see how great that looks. So what we're going to do now is we're actually going to reinstall the keyboard. That's what we're going to do next. So I'll show you how I do that. So now we're getting ready to put the keyboard back in this thing. As you can see, I pulled the harness out to the side, get it out of the way. And I've got our spacers here that go between our keyboard. These are the little wooden spacers that go in this thing. So now these are different sizes. Not all Minimoogs have the same size spacers. So if you're missing these things, I usually have to get a height, measurement, and I'll then actually build these things out of a piece of wood, and that way I can shim them to the right size. So these, you can't just use any Minimoog spacer for any Minimoog. They're kind of unique to the chassis. But what we have here is we got two fatter ones. As you can see, they're a little thicker. They go to the front. The two thinner ones go to the back. And so what I do is I just kind of set them in here like so. I'll just kind of get them over our screw holes in our chassis. I'm not real worried about that right now. Main thing is just get them in here, and once you get them in here, we're going to do everything from the top. So I got those in there. Let me go grab the keyboard over here. And so here's our keyboard. And then what I like to do is I just like to fit it into the top. Work it in there. You won't be able to get it all the way over because your hand's in the way, but I can at least get it somewhat over here. Try to lift up on it just a little bit there so I can keep that front spacer in there like that. And then what I do, I go underneath and I find these spacers and I run the screws through them. It's a little tricky, it's not too bad, but I'll kind of show you how I do this. So here's a look how I install the keyboard. I've got it slid off the table so I can work from underneath. And basically I just line up that little spacer with the keyboard. You can see I've got the bolt through it there, or the screw through it. And that's how I mount it. So that's how I do it. I just get everything lined up from underneath. But now you can see, I'll turn this light out so we don't have that light on there. But you can see now how great that keyboard looks inside this chassis. So looks way better. It actually has a nice feel to it. Good action. It's going to be a really nice keyboard. I turn my attention back to the inside of this thing, and as you can see we got these two screws now, which lets you know this one has a buffer board. So we actually got the buffer board installed. Reran the harness to have it installed there. And for those that don't know what the buffer board does, I've actually got a little short video on there I'll add in this video that you can go to and watch. But what it does is it's a constant current supply for your footages of your oscillator. And what would happen is, without the buffer board, if you change one oscillator footage, it would affect the other two oscillators, etc. So it was a real nuisance trying to keep this thing in tune. But now with the buffer board, you won't have that issue. It won't have the interaction between the footage controls of each oscillator. So that'll help a lot. But yeah, that's about it. I did put some new hardware in this thing. I got these connectors all tightened down now, so they're not going anywhere. And got that all taken care of. But now I'm going to turn my attention to the circuit boards. Something else I did too was I actually added the harness needed for the negative 10 volts for our dead zone mod for the pitch wheel. So got that added as well here. Alright, I now have all the boards serviced here, and I got them ready to go back in here. Got the dead zone circuitry added to our pitch wheel, as well as the oscillator board. That's what these two blue wires here I added are for. And so we got all that done. Got our stickers reinstalled. John had actually sent this to me in an envelope. This had fallen out of the unit. But this is actually the sticker for the left-hand control. And you can see it's April 26, 73 is when it was electrically tested. So this is indeed a April Minimoog. So we're in the month it was actually built, which is pretty cool. And I was looking a little bit closer here at this sticker. I got it glued back in as well. If we look right here, let me see if I can get this thing to focus. I'm having a real hard time with this camera focusing. There we go. If you look at there, the mechanical inspection was done on 4/23/73. So April 23rd, once again. So this is an April Minimoog. So that's pretty cool. So it's April right now in 2025. And this was April 1973, so pretty cool. So that's when this Minimoog was all put together as assembly. But yeah, just a good look inside. Once again, we got the buffer board added. Went through all the potentiometers, took them apart, cleaned them. That's all the little black dots you see on them, just so I could keep up with it mentally. Got all that clean. Of course, we started with the rectifier filter circuitry over there with the caps and rectifiers and power cord and all that good stuff. But yeah, that's a good look at it. So I'm going to start putting this thing back together, and we're going to see what it does here. All boards are remounted here. Now, I decided just to leave the screws out in case I need to work on them, because I'm still not 100% sure the noise source is working okay. I could tell somebody's already been there before. But this is a nice thing too about Minimoogs, is you can actually take the screws out and you can tilt it down, you can work on all the boards like so. With the boards back in this thing, let's go in and check our power supply voltages first, and we'll see how that looks. Now, I will tell you, I did a little bit things off camera here. After I installed the buffer board, I wanted to make sure everything still worked, so I did put the boards back in before I serviced the boards, and I did a rough calibration, so we should still be fairly accurate. Now, I hadn't done anything since I've replaced the op amps, electrolytic capacitors. This will be the first test of the boards since I've done all the maintenance and the dead zone mods and all that good stuff. So this will be kind of new territory here for both of us on this. But the oscillator should still be fairly close in tune with each other, which is great. It'll probably be even better after I do a calibration this time around, since I've replaced a lot of components that tend to go out of tolerance. So we'll start first by setting our multimeter to DC voltage. I'll get that backlight on so you guys can see it. I'm going to take my voltage measurements from our oscillator board. So I'll look at our voltage rails here. So ground, then that should be the plus voltage. Let's go and turn this thing on and see how our voltages look. Right there at 10.003. That's really, really good. That number will change also as this thing warms up a little bit. It's cold right now. This should be our negative voltage. See what it reads. And negative 10.002. That's perfect. So that's really good. Let's check our negative 5 volts. It's good, negative 5.00 volts, right on the dot. I just connect my meter back to the 10 volts there, the plus 10, just as a keeper. Let me go around to the front and let's see if this thing actually produces sound, how the oscillators work. They should still be fairly close. They may be out of tune with another instrument, but they should be still within tune within each other. But here's oscillator 1 only. Let's see how it sounds. Sounds good. So that's oscillator 1, here's oscillator 2. Oscillator 3. definitely needs a new calibration done, but the oscillators sound great. So that's with all the new components we replaced. Let's see how the dead zone works. So I've got the LHC just pulled out right here. Just oscillator, we'll just leave oscillator 1 on here. Let's see if the dead zone works okay. It shouldn't have any effect in tuning until I move outside the detent. Perfect. It's working great. That's fantastic. So that's great. The only other thing I need to check, let's check our noise source. That was an issue we did have, and I have not done any kind of repair work there. I just did the servicing. So in the servicing what I did, I just replaced the coupling capacitors for that, because sometimes they dry out and you lose your decibels because of a bad coupling circuit. So those are all new. Let's see how this works. That's still weak. Yeah, that's still real weak. Okay, so we need to troubleshoot the noise source at this point. That's the only thing I think that's really a problem. Let's check, make sure our filter still works okay. Let's go into self-oscillation. 440 Hertz, it works. Filter works great. Envelopes work. Sounds great. Filter's working great. Looks like our loudness control is working okay. Yeah, so everything's working great there. It's just our noise source. So let's go back to our noise source and see what's going on there. I'm going to leave it powered up here for right now. And actually I'll turn it off back here when I get back here. It's going to kill power. And what I do for this, let me get my strap out of the floor. ESD strap. Strap back up here. And what I do for this is I actually pull the filter board. I'll just pull this out of there. You can run it without these boards in there. The only two boards you cannot run with them out is the oscillator board and the power supply board. Those have to be in position because your oscillator board has your sensing circuitry that works off your power supply. So you'll have some issues if you try to do something like that. You can still run it, but you'll see that your voltages are going to do some weird stuff. You really can't troubleshoot as well like that. But let's see. Let's go. We'll leave our ground on our oscillator board, and what I'm going to do, I'm going to set over here to our decibel. We'll look at our decibel output on our meter here. Let me go to C18. Right there, C18. I've already been through these things so many times I know which cap to go to. We're going to look at the white noise. Let me get a screwdriver. See if I got a screwdriver. Here's a screwdriver right here. Sorry, I'm walking in front of the camera. Apologize for that. So what let's do is turn it back on, and we should have -5 decibels is what we're looking for. And you got a trim here, you can adjust that. I've got it bottomed out. Actually, it was already bottomed out when I opened this thing up, so I know there's been a problem there. And I could also see old flux. So somebody's already been troubleshooting this this noise source here. Let's turn it on. Let's see what we got. So our decibel is give it a minute to stabilize. Yeah, we're -29 decibels. So going this way clockwise, it'll just bring that up. As you can see, so we're just going up in decibels. So yeah, -4, or actually going down in decibels because it's negative 48, and then that's negative 20, 29. That's as low as I can go. So we definitely got a problem there. Let me look and see what our actual noise source is doing. I'll look right off our noise source circuit. Let's go here. Look at this coupling capacitor here. 60. Yeah, I bet we got a bad noise source transistor. Yeah, this is discrete, so it's actually using a transistor to make the noise. And by looking at that, we're looking right at the output of this. And I go to the plus side of that cap. Yeah. Okay. So it looks like our noise source is probably no good. Our actual transistor that makes up our noise. If it looks okay, if you see a decibel level looks good there, then typically it's a problem with your gain. But yeah, this is before we actually even get to gain. It's already really too low. It's negative 68. So we don't have anything really to work off of. So that's where we're going to start. We'll pull this out. I'll have to match a transistor for the noise. That's something I have to do here because you can't get these transistors. You just have to match one that has a good decibel. And so that's what we're going to do. But anyways, I'll bring you guys back after I figure this out. So here's our actually noise generator circuit here. And so what you're looking at, this is actually the noise generator transistor right here. Now, it says a 2N3392, but this Minimoog does not use a 2N3392. In fact, most Minimoogs I get in here do not have a 2N3392 used there. It's usually like a 5117, which is actually a Thomas organ part. You find them in the crybaby pedals. That's actually what they use as the noise generator part of this. So what happens is the collector floats. You can see it has no connection here to the collector of this transistor, and so it just randomly generates noise because there's no reference. And then that goes into the circuitry here, which actually drives it and amplifies it. And this is actually where you adjust your noise level. And then it goes through all these stages of filters to get your different noise. So, of course, right off of it, it generates white noise. So there's our white noise. It goes through all these filtering and then buffers, and comes out here as pink noise. And then it goes through this section here. And then we get red noise for the modulation bus. So that's kind of how that works. And so our decibel's way too low over here. I've checked all these components, make sure we didn't have any resistors out of tolerance. I've already replaced the coupling capacitors and all that good stuff. And of course that's a tantalum capacitor. I've checked it as well, and it's at 5.7 microfarads, so it's still real good. So our problem is just right there at the decibel level of that actual transistor. So I gotta see if I can select one and get our decibel level up where we need to have it. Alright, I have us a transistor selected. As you can see, we're running at negative 5.0. It fluctuates just a hair on the meter, but we got it set. What I ended up using was a 2N3904, an old vintage stock 2N3904, so I get the right noise. So this comes up to the big thing is about modern components, low noise. Sometimes you want noise in this case, so you have to kind of like try to find a component that has more noise than what most modern components have. This is a good example of that. But looks like our noise source fixed. Let's put our filter board back in here and just kind of see how this thing sounds real quick. Alright, let's test this noise out right quick. I got the filter board back in here. Let me turn power back on. Turn the oscillators off. Here's just the noise source. Much better. That's great. So that's just our noise source. I can control the volume of that with the pot we cleaned. Alright, so noise source fix. Let's see if the modulation works with noise, because that was something that didn't work because of that decibel being so low. So let's go, here let me go to noise on our modulation mix. We'll engage it to the oscillators. Actually, we'll engage it to the filter. Filter would be a better setup for this. Let me go here and make this thing sustain for me. Get the filter and self-oscillation. Alright, there it is. So noise source is all fixed. That's great. So noise source is working. So this Minimoog is ready for burn-in and calibration is where we're at with it at this point. So we'll be pulling these oscillator card and the filter board back out so I can put the screws back in the boards. And I'm going to let it just warm up. And while it's warming up and doing a burn-in, I'm going to finish cleaning up some things because I still got the knobs to clean up. I got to reassemble the LHC panel. But that's looking great. So that was the last thing we really had to tackle on this one, and we got that fixed. So I'll bring you guys back when I get the knobs all cleaned up and get this thing ready to demo for you guys. Alright, we now have this Minimoog all complete. I've got everything put back together on it. As you can see, it looks really, really great. Everything's cleaned up really good. You can see how nice that wood looks. And like I say, we left the lamination on the front panel as requested by John. He wanted to keep that kind of vintage look going on with it, and so we did that. It's also got some broken knobs, which we also kept. They're not broken in the sense that they don't work or function, it's just that they got little chips in them, like that one right there. And then we've got, I think this one here has got a chip in it. Yeah, it's got a little chip right there at the back of it. And I think we got one more that's chipped. I think it's this one right here. If we turn this knob here, you can see the chip in it right there. So a few little scars and marks there that we just kind of kept, just to kind of keep it, you know, what it is. It's kind of the history of this instrument in some ways. But we did focus on everything that needed to be focused on electronically, as you guys have seen through this process. And it turned out really nice. Of course, the keyboard's all nice. You can hear that it's nice and quiet. There's no longer clanky notes. That's what new bushings do for you there. So really nice and quiet there. But LHC is about the same way. We kept it looking very much original. Cleaned the pitch and mod wheel though. I did take those out. Dead zone mod, all that good stuff. But once again, you can see how pretty that wood looks since I've conditioned it. You can see it's starting to look kind of normal. It doesn't have the real heavy shine on it. So it looks really good all the way around. Around to the back of it here. Got this thing all cleaned up along the top here real good. As you can see, it looks really good around the top. Once again, this is the 2312 serial number. And it's built April 26, 1973. And it's currently April 16th, 2025. So, pretty cool. It looks really good. New power cord. Clean the back of it real good as well. Clean the inside of it real good. Of course, still got the original badging on this one as well. So everything looks really good all around there. Bring it on around this way. You can see how great it looks. It's a good looking Minimoog, great playing Minimoog. I also put the screws in this top bar. Now this top bar did get a little darker when I put the conditioner on it, because I want to condition it as well. So it is a little darker wood, but not bad. It looks pretty good there. But anyways, let me get the camera on the tripod here, and I'll make you guys a sound demo. Alright, so let's do a direct audio recording now of this thing. So I'm going to start with a keyboard circuit, and I'll show you that all the keys are working okay. So I'll pin down the highest note. I've got oscillator 1 on only, set to 8 footage. And I'm going to go down the scale of the keyboard while holding this highest note, and you'll hear that the notes are squirrely. It has really good accurate keying. So here we go. So you can hear they sound really good. Glide works great. So there's the glide. I also going to show you the dead zone mod real quick for the oscillators. So oscillator 1 still on only. You can see before I could just touch this wheel, like just bump it like that, and we get tuning differences. Now you'll hear that it doesn't do that. See how great that pitch wheel works now. So that's all fixed. And now we'll just go through the oscillator section. I'll take you to the filters, envelopes, etc. here. I'm just going to combine all the 3 oscillators together. How accurate those footages are now with the buffer board added. So there's that. And then we'll go back to oscillator 1, go through the waveforms. I'll go to 16 footage, and we'll go through all the waveforms. Here are the waveforms there. Also the volume knob, I cleaned it. Nice and clean. So that's oscillator 1. Here's oscillator 2. Go back 16 on it as well. You can hear once again the volume knob on this one. There's oscillator 2. Here's oscillator 3. Next you'll go triangular wave. Reverse sawtooth on this one. Sawtooth. Square. It's pulse, and here's the more narrow pulse. Good clean volume punt there. So there's all 3 oscillators. So anyways, you know how great those oscillators sound? They sound really good. Set them all back to 16 footage here. And sawtooth. Now I'll turn the oscillators off here, and I'll show you the noise source works, which is what I had to fix. Now you can hear that it has a good volume. So there's our noise source. And then now I'll go to the filter. So for the filter, we'll make it self-oscillate. And I'll set it to where it tracks the keyboard, key tracking on. So here's just the filter. See how it tracks the keyboard. Something I love doing with the filter is just put a little reverb on it. A little glide. We'll add some modulation from this Oscillator 3. We can also introduce noise into this. Put just a little noise in that though, and it just does this kind of cool. And that's all just the filter you're hearing right now. We can combine the oscillators back with that. And you can also hear the loudness control working there a little bit too. So just a little bit of all that combined there. But yeah, that's just kind of a cool approach using the filter as a oscillator source. So now you've heard the filter. You kind of heard the modulation section. Let me go back to the oscillator since we're kind of talking about modulation. And I'll show you the oscillators modulate here as well. So let's open this filter back up. This thing to sustain for me. So anyway, you hear the noise, so we can come back over here with our modulation mix. Now we're using Oscillator 3. We turn key tracking on. Get some real Devo kind of stuff here. So anyways, that's the modulation bus there. I will show you these right quick too, going back to oscillator real quick. I didn't show you the detunes. So go ahead, set everything to 16 footage. So here's oscillator 2 detune with oscillator 1. So oscillator 2, here's oscillator 3. So there's the detunes of those two. So now you've heard the modulation bus, the oscillators, the filter. So we'll go back to the filter and I'll show you the envelope generator for the filter. So turn the oscillators back off, we'll put the filter into self-oscillate. And then now we'll bring up a mounted contour. We'll set everything to 0 in our envelope contour for the filter. So we'll have attack. Bring the filter down in frequency. That's our attack. Here's our decay. We can set our sustain level. To get something like that. Basically, that's how low the decay goes. So you hear it's going to drop all the way to 0. We can turn all the way up. So there's that. We also have the decay switch over here which works with it as well. So you see it follows out the decay. Without the switch, I have to hold in the key and it'll follow it out. So that's working. So that's your filter envelope or contour. Open the filter back up, turn the oscillators back on here, and I'll show you the loudness contour. You've already heard a little bit, but I'll show you it again. So now I got everything set to 0. It's going to be just a click. Start with the attack here. There's your attack. Here's your decay. So here it gets a really long decay time, and we also got the sustain level once again, just like we had for this. What I like about this, you can put a little bit of decay on it. It doesn't die all the way out. Allows you to get those percussive kind of sounds. Of course, you put noise on that, close the filter up a little bit, get the filter track in the keyboard. You get this nice kind of percussive. that's pretty much the Minimoog. I will show you too just some sounds here. We'll go through some sounds on it. If you just saw that light, my refrigerator just kicked off. Anytime my refrigerator kicks on or off, it always interferes with the overload light on Minimoogs, just so you know. Kind of ring modulator effect there. Just some fun there with the filter, some L-film synthesis kind of stuff there. But anyways, you can't beat the sound of these old vintage Minimoogs. They just sound great. But anyways, John, just want to give you a special thanks for letting me work on your Minimoog here. And really do appreciate it. And to all you guys that watch my videos, really do appreciate you guys watching. And there'll be more to come here very soon. Take care. And we're not done with Minimoogs just yet, because we've got these next. So Sam, this is your Minimoog. It came all the way from Australia. Serial number 3278 is this one. So it's a 73 Minimoog. And then after that one, Keith, you're up next. So here's your Minimoog, Keith. Right there. And it's serial number 3118. So they're all 73 era Minimoogs right here. It's kind of rare I get all the same era, but they're all 73. So look forward to those videos next.